defined in this simulation software, and you can use them, but it's recommended to define everything from the first steps by your own. Okay, because you can change anything. Here, I want to enter a new case. As I told you, the first step is to define the component list. The next step is to choose the appropriate equation of states or fluid package, and then we are going to enter the simulation area. Okay, we need to know what are the components here. You can see I have inserted the table here, and we are going to, sorry, I should change it properly. We should enter what components are available, and you can easily search for different components. Nitrogen, H2S, CO2. These are the most common components available in the gas, yes? And from now on, methane, propane. As you know, butane has isomers. Isobutane and normal butane, yeah?
Yeah.
Do you know what is isomers, guys?
Yeah, it's different by the boiling points and
Exactly. Same chemical formula, but different physical properties. And what do we have here? We have methane. What is the next one? Methane, normal methane.
C5,
And defining the components is as easy you can see here, okay? But these are the predefined components. Even you can define some sealed components with new physical specifications, okay? We don't want to enter that, but it's available and you can use it. So, and heptane, and of course the water is the last component that we want to define here. Okay. Yes, yes. Is it complete according to that table? Okay. So, as you can see, we have done and we have defined the component list. Okay? It's time to choose the proper fluid package. And for this situation, we are going, as you can see, this is the list, okay? For different processes, it's very important to choose the right fluid package. Here we want to choose Payne Robinson. And whenever you choose the fluid package, you should come over here and check if all the binary coefficients are defined or not. Sometimes when you choose the fluid package, the fluid, yes, it's not appropriate, and some of these binary coefficient is not defined. Now it's time to enter the simulation process. Okay?
For normal hexane, I've done.
You should check here what are all the binary coefficients defined or not. And as you can see, all of them is defined. It means that the fluid package is suitable. Now it's time to enter the simulation. Okay? So, you can see a lot of different equipments are defined here, and we can use different equipment simulation. And if you remember, we said we can use simulation software for simulation, breaking, and design. Okay? And here are different streams defined. This is the flow stream or material stream. And as you know, you can consider them as the piping. Okay? So the first step here, according to the diagram, is to define a stream. Okay, the fluid stream is inserted. Now I should enter what is the composition of this stream. Okay? We are going to insert the amount of composition that we have. And you can choose what composition basis is selected here. Here we are going to choose the mole fraction. You can even insert the composition according to the mass fraction and others. Okay?
صفارة 5 إذا كنت صفارة 3 عندك ما أدري صراحة شيء كذا صورة
لازم نشوف 7 5 7.
Okay, guys, whenever you enter the composition, the thing that you should check is here. The total amount of fractions entered or molar should be 1. But as you can see here, it's not 1. What can I do here? I can ask the simulation software to normalize it. It's going to change and it will adjust anything for us. Okay? So, the first step for defining stream is done. I know what are the compositions. The next step is to define the conditions. Look at here. We can define different items for a stream. By just knowing 2 of these 3 items, I mean the temperature, pressure, or vapor phase fraction, I can calculate the other. Here we have the temperature, which is 37, and the pressure is 130, and you can change the unit here. As you can see, the defined temperature and pressure lead to calculate the amount of vapor phase fraction, and of course the enthalpy and entropy of the stream is defined. So yesterday we talked about a lot complicated formulation to calculate the enthalpy and entropy. But here, just by defining the composition and defining the pressure and the temperature, I'm able to see how much is the enthalpy and entropy of the stream. Now, the last item that I should enter is how much is the flow rate. Okay? As you can see here, I can enter it with different units. The volumetric flow, mass flow, or molar flow. And if I just enter one of them, it can calculate everything. As you can see, you can get rid of complicated formulations by just using this software. And it's very interesting. Here we have the molar flow, yeah? So I should enter the molar flow here. everything is done. Now I can see anything required for the flow stream. And as you can see, it's very user friendly, okay? And it's really easy to work with different things. And even you can define different analyzes for the stream. You can find out at what temperature the hydration is going to be happening. Okay? And it helps you a lot. Just entering the composition and flow and temperature.
Could you please get back to the condition list?
Yeah?
How did you choose
Here, we will.
yeah, that's
I should know how much is the flow rate, okay? Here I have the molar flow. For your process, if you have the volumetric flow, you can enter it in this section. Just one of them is required, not all of them. Okay? When I have the composition, it can change everything together. Tarek, what did you do? Is it okay?
When I choose the model for the composition, I don't know why. When I choose the
Let's get